what is the difference between regular linear models to generalized linear models? Well, linear models date back to the early 19th century or even late 18th century. It mainly came to life thanks to this guy, Carl Friedrich Gauss. Now, what do we want? What we want is a way to relate between an outcome variable or a response variable, which is often denoted by y, to some predictor variable. In the 2D case, let's consider just one, which is x. We have all kinds of data points, and we want to fit some regression line. Now, linear models make three assumptions. One, that the y's are independent. Our observation are independent of one another. That means that if I know this value over here, it doesn't tell me anything about the next value. The second assumption is that each observation comes from a normal distribution with a mean mu I and a variance sigma squared. The third assumption is that the means mu I are related to the predictor variables xi by a linear model. So xi transpose beta. And what needs to be linear here are the coefficients, are the betas. Yeah, so this can be beta 0 plus x1 beta 1 plus x2 beta 2 and so on. Now it doesn't matter if the x's are transformed, like x2 can be x2 squared, x1 can be square root of x1, x3 can be ln, natural log of x3. But the most important thing is that the coefficients remain linear. This is what it means by the linear in linear models. Generalized linear models came almost 2 centuries after by two fellas named Nelder and Wedderburn. This guy over here is Nelder. And it takes the linear models and it generalizes it a bit. What it does, it takes the second assumption, and instead of saying that the y's are coming from a normal distribution, it says that the y's are coming from any exponential family distribution. And in an upcoming video, I will show exactly which distributions belong to the exponential family and which are not. For now, it just suffices to say that the normal distribution is a part of the exponential family. And in addition to this, it also says that it's not necessarily that the means are related to the predictor variables themselves, but it could be that some function of the mean, so some function of the mean is related to the linear predictor. So some functions, this can be a logit, this can be a log, and this can be an inverse, and some other functions. The fourth thing that is really the difference between these two is the method in which the coefficients, the betas, are found, the method which is used to find these coefficients. So in regular regression and regular linear models, you can use either least square or maximum likelihood. And they both will give the same result, and the reason why is that under a normal distribution, maximum likelihood is exactly like least squares, whereas here in the generalized linear models, you have to use only maximum likelihood. And in the next video, I will go into details exactly as to what are the differences between ordinary least square and maximum likelihood. But for now, it's just important to realize that Even though least square is from early 19th century and generalized linear models, GLMs, are from the late 20th century, you can think of least squares or linear models as a special case of the more generalized linear model, or GLM. See you in the next video.